Hi everyone, I'm Cheryl. In this problem, we're asked to evaluate a double integral and then sketch the region over which we're integrating. So let's begin by taking a look at this integral. Well, I'm going to start with the inside piece. So that means I'll be integrating r dr from 0 to 2 cosine theta. So I'm going to have the integral from 0 to pi. And then if I integrate r dr, that's going to be r squared divided by 2. And I'll evaluate that from 0 to 2 cosine theta. And then, of course, I still have my d theta for my outside integral. Okay, so plugging in my upper and lower limits of integration, I'll have the integral from 0 to pi, and this is going to give me 4 cosine squared theta divided by 2, and then I'll subtract what happens when I plug a 0 in, but that will be 0 squared divided by 2, which is 0. Right? So this is still a d theta. This will simplify to the integral from 0 to pi of 2 cosine squared theta d theta. All right, so now I have the inside integral complete. Now I can work on the outside integral. Looking at this, I know I need a power reducing formula to help me here. So I'm going to write this as the integral from 0 to pi of 2 times the quantity 1 plus the cosine of 2 theta all over 2 d theta. And again, that's a trig identity. This reduces to the integral from 0 to pi of the quantity 1 plus cosine 2 theta d theta. Now I'm ready to integrate. The integral of 1 d theta is just theta. And the integral of cosine of 2 theta, I need a small u substitution for this, but I'm just going to write this as 1/2 sine of 2 theta. And I can evaluate that then from 0 to pi. All right, what comes next? I need to plug in my upper and my lower limits of integration. So I'm going to bring this up here. And plugging in a pi, I'll have pi plus 1/2 times the sine of 2 pi. Then I have to subtract what happens when I plug a 0 in, which is going to be 0 plus 1/2 times the sine of 2 times 0, which is just 0. All right, so I'm going to end up with pi, and the sine of 2 pi is 0. 1/2 times 0 is 0. So this is just a 0. I'm going to be subtracting 0. The sine of 0 is 0, so this whole term is 0 as well. My final result is pi. Okay, now let's talk a minute about what region I was integrating over. I get that region by looking at the limits of integration. And I can tell that my region is going to be the set of points r theta, where r is between 0 and 2 cosine theta. So 2 cosine theta. And theta is going to be between 0 and pi. Okay, now what does that mean as far as my graph is concerned? Well, I know from using polar coordinates that 2 cosine theta is a circle. It's a circle whose center is the point 1, 0 and has a radius of 1. So it's going to go through the points 0, 0, 1, 1, 2, 0, and 1, negative 1. So let me sketch in a circle just with a dotted line here. to get an idea of my circle. I also know that theta is going to be going between 0 and pi. So how much of this circle do I want to include? Well, if I start at 0, then 2 cosine of 0, that'll be 2 times 1. That gives me this point. So I'm going to start out with 2 here. And as I move around, let's say, for instance, that theta equals pi over 2. The cosine of pi over 2 is 0. That's giving me this much of the circle, because now the r value is 0. At pi, cosine of pi is -1, so r will be a -2. So at pi, I'm going to be plotting -2, which takes me back to this point. So that finishes up my circle. So for this particular region, I've gone the whole way around that circle. I hope that was helpful. Thanks.